Hi, welcome to the today's session on taper roller bearing selection from manufacturer's catalog. Myself, Professor Kushare. Objective of today's session to explain basic procedure for the selection of a taper roller bearing from manufacturer's catalog. After this session, you will be able to select a taper roller bearing from manufacturer's catalog. We know very well, as discussed in earlier sessions, the construction of a roller taper bearing. It consists of a two main parts. One is a cone, another one is a cup. So you know very well the inner race. It consists of here. Look at this. The cone, cage, and rollers or a rolling elements is called a cone, and outer race is called a cup. But here cone and cup, they are separable from each other. And here this separable assembly of a cone consists of cone, cage and rollers. You know very well the arrangement of in a taper roller bearing, axis of this individual roller which is going to intersect to the common apex point on the bearing axis. Try to understand. Again here, this taper roller bearing, it is going to subject a load of radial as well as the axial load, and it withstand both radial as well as axial loads. And its construction is separable when you are going to compare it with a deep groove ball bearing. Again here, because of this rolling element which is inclined here, the axis which is inclined with the axis of the bearing, because of that, the resultant reaction or the reaction of this roller taper roller bearing have a radial as well as the axial component. Again here you will find in case of conical roller bearing, when it is subjected to pressure acting normal to the surface, because of this, what is going to happen? There is a thrust reaction because of just pressure. Try to understand. Even though bearing is subjected to pure radial load, even though there is no axial load, but it induces a thrust reaction. How to cope with such a problem? Because of this thrust reaction, there may be possibility of separation of a cup from a cone, and therefore this reaction is balanced by an equal and opposite force using two bearings. So what is the important thing compared with single deep groove ball bearing? Generally, two bearings are used or pair of taper roller bearing which is used in many applications. Try to understand, not a single taper roller bearing which is used. Why we are using two bearings? Because of this thrust reaction, and to take the care of to avoid the separation of a cup from the cone, this reaction is balanced by equal and opposite force using a two bearings. And always two taper roller bearings or taper bearings are used in many or almost all applications. Again, these two taper bearings, how they are mounted. Here you will find there are two mounting arrangement. One is face to face and second one is back to back. Let us see what you mean by face to face mounting. Now here in face to face mounting, the construction, it involves the two bearings with their faces. Look at this here. This part is the outer ring, or we are stating it as a cup, and this part is known as the inner ring. We have already mentioned it as a cone. But here you will find in face-to-face mounting, two faces here. So in this case, two bearings with their front facing each other. This is face of this bearing, this is face of bearing, and this is the journal. While mounting it, the two faces with each other is called face-to-face mounting or direct mounting. Try to understand. This is one arrangement. And here the center line of the rolling element, which is going to meet at the apex point to this axis of the bearing. Then second arrangement is back-to-back mounting. In back-to-back mounting here, two bearings are mounted on the shaft with their backs. Backs means this. Look at this. This is the back side of the bearing one and this is the back side of the bearing one. Here in between, maybe helical, axial, worm or a bevel gear may be mounted on it. That arrangement is back-to-back, where this axis of the tip rolling element which is going to meet at the apex to the axis point in between these two bearings. Try to understand. This is back-to-back mounting. These are the two arrangements of the mountings of the bearings. So while selecting the bearing, you have to take the care of this mounting, whether it's a face-to-face mounting and whether it's a back-to-back mounting. Because these mountings, because of this, you will get a idea of a axial load which is acting on the bearing. Again, here main important things. While selecting the taper roller bearing, you have to consider some of the important factors. And these factors are the operating condition of the bearing. Operating means whether it is subjected to purely radial load or combine along with this radial thrust load, or only thrust load along with some the magnitude of radial, or combination. That means we have to check the performance as well as the operating condition of that application, or which type of load which is coming on the shaft. Then second, mounting arrangement. Mounting arrangement means whether it's a face-to-face mounting or a back-to-back mounting. Then next one is the bearing size. Why bearing size? Because here in nomenclature we have discussed how to select how the different numbers designate the bearing. So here you will find at the size of the bearing is going to increase, the cost is also going to increase. Even though for a same diameter shaft, 3 to 4 bearings are available in standard sizes. That's why bearing size also plays the important role. Then lubrication. Lubrication is one of the important factor. And last one is the temperature and the speed. As the speed increases, temperature is also going to increase, and which is having a relation with the lubrication also. That's why while selecting the bearing, we have to take the care of these important factors. Now let us see, as per our objective, how to select the bearing from manufacturer's catalog. In first step, what we have to do? We have to find out the diameter of the shaft. In earlier topic also, we have discussed how to select the ball bearing or deep groove ball bearing from manufacturer's catalog. In this case, we are going to see how to select the taper roller bearing from manufacturer's catalog. So first of all, our target or main objective should be to find out the diameter of the shaft. Look at this here. This is the shaft, helical gear which is mounted on it, pulley. Again, it transmits power or a torque horizontally. Two bearings are there, and assume it's a taper roller bearing. So what is going to happen? First of all, you have to find out the diameter of the shaft, because once you will get the diameter, in the catalog, in manufacturer's catalog, you will for different diameters, different width, outer diameter of the bearing, dynamic load capacity of the bearing, E, thrust factor, everything is available. So because of that, we can easily find out the different bearings available for the different diameter of the shaft. Try to understand. And how to find out it? The diameter, you know very well, already we studied this, how to find out the diameter of the shaft. For that purpose, you have to calculate the radial as well as the axial forces acting on the bearing. Try to understand. This is the first time. By doing this calculation, you can easily find out the diameter of the shaft. Now, second, next important point, what we have to do, we have to calculate the axial forces acting on the bearing to determine the thrust component created due to radial load. Radial load means even though bearing is subjected purely radial load, because of the inclination of the rolling element, the axis which is going to intersects at the axis of the bearing, or generally we are saying it, this point is apex point, we will get the thrust component because of this inclination, and that's the value or magnitude of this thrust component can be determined by using this relation. Ap is equal to 0.5 into Fr by Y, where Y is the thrust factor, and if you don't know the value in preliminary stages, you can assume Y is equal to 1.5. Then it's a thrust component created due to radial load. But in different application, you know very well, helical gears, bevel gears, worm gears are mounted on the shafts. And because of this, helical gears, because of the helix, there is a thrust component. In bevel gear, there is also thrust component. In one worm and worm wheel, there is also a thrust component. And how to find out the magnitude of this thrust load? So what we have to do? We have to calculate the thrust load for various bearing arrangements. Various bearing arrangement means we have to, whether it's a back-to-back mounting, whether it's a face-to-face mounting, whether axial load acting towards the right hand side, whether it's act towards the left hand side. Based on that, the different cases that we have to take into account, and we have to use a different relation to find out the F axial component for bearing A and bearing B. That means, as stated earlier, generally two taper roller bearings are used. We can't use a single taper roller bearing. Try to understand. That's why two bearing, that's why one bearing is A and second bearing is B. That's why axial component of bearing A or bearing B, or in other word you can say bearing 1 or bearing 2 also, no problem. So what we have to do, we have to use the different cases. Now let us say these different cases and different, the bearing arrangement to find out the axial loads. Now here in case 1, so you will find here two arrangements are shown for case 1. In this case, this arrangement is back-to-back arrangement and this arrangement in face-to-face, because these faces, look at this, these are the faces, and here is back-to-back arrangement, backside and backside of this bearing. But in this case, suppose this is bearing B, bearing A, here bearing A, bearing B, but K, axial or thrust load, which acts towards the right-hand side, and in this case, it acts towards the right-hand side. In case 1, this K acts towards the right-hand side. Try to understand. Arrangement may be back to back or a face to face, but how to use these different cases to get here this in column axial loads equations are given. We have to use this equation to find out the axial load. But when to go for this one equation, equation 2, equation 3, that you have to decide based on the load cases. Now let us see case 1. Arrangement may be back to back, face to face. But if look at this figure for back-to-back arrangement. If this FRA is greater than FRB, means radial load at A bearing and radial load of B bearing, the radial load at A bearing is greater than load B. And if this K is greater than 0, then what you have to do to find out the axial component, you have to go for this equation. FAA is equal to, that means axial load at bearing A is equal to 0.5 FRA by Y, and FAB is equal to FAA plus K. Then case 2. Case 2 means here of the subpart of the case 1. In this case, you will find if FRA is less than FRB and K is greater than 0.5 in bracket FRB minus FRA. That time we have to use the same equation. Look at this. These equations are same. There is no any change. Only you have to check whether K is greater than 0.5 FRB minus FRA or K is greater than 0. But here FRA is less than FRB. Here FRA is greater than FRB. By using this, you have to check it by putting the values of radial load and K, and you can decide whether you have to go for this equation or this equation. Similarly, again here the part 3 of the case 1, if FRA is less than FRB and this K is less than 0.5 FRB minus FRA, that time you have to go for this equation. Here equation is going to change. FA is equal to FAB minus K and FAB is equal to 0.5 FRB by Y. That time you have to go. Arrangement may be back to back or face to face. Just you have to check whether FRA is greater than FRB or K is greater than 0, or FRA is less than this FRB or K is greater than 0.5 FRB minus FT, and similarly you can check for this condition. Then you can use this expression according to your load case or load condition, where K is the external axial force acting on the shaft. That means suppose on the shaft, if helix gear is mounted, because of the helix angle, there is an axial component that is you have to take into account by Ka. Try to understand. Then case 2. In case 2 arrangement, you will find back-to-back arrangement, face-to-face arrangement. Everything is same. Only here, what is the change? This Ka. K means external axial force acting on the shaft, which acts towards the left-hand side. Look at this direction, left-hand side, this act towards the left-hand side. Again, what you have to do, you have to check for case 2, part 1, part 2, part 3, different situations based on the load conditions, whether this FRA is less than FRB or K is greater than 0. You have to check whether FRAB is greater than FRB or K is greater than 0.5 in bracket FRA minus FRB, or FRA is greater than FRB, K is less than 0.5 FRA minus FRB. By using these cases, what you have to do, you have to use these equations. FAA is equal to FAB plus K, FAB is equal to 0.5 FRB by. If it satisfies this condition. If back-to-back or face-to-face arrangement, which you are going to take, whether it satisfies this condition, you can check, or you can use this equation. Similarly, you can this equation. That means from this case 1 and case 2, whether K is acting towards the right hand side, that is external axial force, or whether it is acting towards the left hand side, based on that you have to find out the axial loads at bearing A and bearing B by using these expressions based on the different load conditions. Different load condition means these conditions. Try to understand. Then, after that, what you have to do? Once you have a shaft diameter, so what you have to do? You have to check the dynamic load capacity. Here, in different bearing taper roller manufacturers catalog, this table which is given or in data book also it's available. Now I am referring Vivi Bandari's book. They use the escape catalog, and that's why it's a data which is taken from the escape catalog. You will find here dynamic load capacity. D is small d is the general diameter or a shaft diameter, capital D outer diameter of the bearing, B is the width of bearing, C is the dynamic load capacity. It's a designation. I have already discussed this topic with you, how to designate the bearing, how to identify the bearing by using the bearing number. Again, E and Y is the thrust factor. Now here, see, suppose shaft diameter is 20, you have these four options, 1, 2, 3, 4. Out of these four bearings, you can select any one, but as I have discussed the number of factors, the bearing size, so you have to start from the lower towards the higher side, because as the bearing designation is going to here, the dynamic load capacity is going to increase, bearing size, look at this, width is also going to increase, and the outer diameter of the bearing is also going to increase. That means size of the bearing is going to increase, only journal or shaft diameter remains same. Try to understand. That's why here you have to refer the chart to get the value of E, Y, C. Why this chart is important? Because to find out the equivalent dynamic load, E plays important role. Based on that E, we have to use the different equations. Now in step number 3, now let us calculate the equivalent dynamic load. Here in a deep groove ball bearing, we have used P is equal to FR or A P is equal to X FR plus Y equation. But in this case, the equation is different for this taper roller bearing. So what we have to do, we have to calculate the equivalent dynamic load from the equation P is equal to FR. That means equivalent dynamic load P is equal to radial load when FA by FR is less than E. Suppose at bearing, what you have to do, you have to calculate the axial load as well as the radial, and you have to check whether it's less than E or greater than E. Where you will get the E? Suppose shaft diameter is 20. If I am going to select this first bearing 32004X, E is equal to 0.37. If this E is 0.37 is greater than FA by FR, so you have to go P is equal to FR. But if FA by FR is greater than the 0.37, then you have to use this equation. P is equal to 0.4 FR by plus Y into FA. Y is the thrust factor, P is equivalent dynamic load, and FA and FR are the radial load and thrust load respectively. Try to understand. The important thing, why we have to refer the catalog or this data or this chart, just to have a value of this E and Y, and based on that we can check whether you have to use this equation or whether you have to use this equation, and this equation depends on FA by FR less than E and FA by FR greater than E. Then step number 4, while selecting the bearing from the catalog, we have to decide the expected bearing life, and we have to make a decision about the expected bearing life. And to select the proper size of the bearing, there is a need to specify expected life of the bearing. For vehicles, in automobile vehicles, speed of the rotation of the wheel is going to vary, and because of this, life of this vehicle or bearing life is expressed in terms of millions or billions of revolution. As we are going to shift or change the gear, accordingly, you know very well, the speed of rotation is also going to vary. And for this varying speed rotation, we have to use the term to express the life million revolution. But in some of the applications, speed of rotation is relatively constant. Generally, electric motor which is connected to compressor without a gearbox, so you will find the speed which is constant. In such a cases, the life is expressed in terms of hours of service. Now let us see. You have to refer the different table here to make a decision about the expected bearing line. Suppose, as I have told, automobile cars speed is varying 50 million revolutions, that we have to assume. Then for a trucks 100 million revolution, for a trolley cars 500 million revolution, railroad cars 1000 million revolution. And again here you can convert easily that million revolution into hours. And similarly, for a constant speed, suppose machines used to intermediate applications such as lifting tackle, hand tools or household applications, the bearing life that we have to assume in hours, that is 4,000 to 8,000. Machines used for 8 hours of service per day, such as electric motor and gearhouse, we have to assume life in hours 12,000 to 20,000. Because here all these are the constant speed applications. And for 24 hours per day service here, what we have to do? We have to assume a life 40,000 to 60,000 hours. And this hours life we can convert into million revolution by using this expression. L10 is equal to 60 into n into L10h upon 10 raised to 6, where L10h is the rated bearing life in hours, n is the speed of rotation. By using this expression, we can easily find out the L10. That means here, by using this expression, we can easily convert life hours into million revolution into hours. But in our equations of load life relationship, the life should be in million revolution. So we have to make a decision whether the expected life in million revolution or the bearing life in hours based on the varying speed or a constant speed, that we have to do. Then next step is, once you know the life, so we have to use a load life relationship to find out the dynamic load capacity of taper roller bearing. And we know very well, we have already used this equation for a deep groove ball bearing also to calculate the dynamic load capacity. L10 is equal to C upon P raised to small p, where L10 is the rated bearing life in million revolution, C is the dynamic load capacity, and P is the equivalent dynamic load, and small p, that is equal to 10 by 3 for a taper roller or roller bearings. We have to substitute the P is equal to 10 by 3 and find out the C, because here we have to calculate the dynamic load capacity of the taper roller bearing, and we are going to compare it with this chart as earlier discussed with you. If this calculated value is less than this, you can say this bearing is suitable. If calculated is value is more, then you have to go for the another bearing version 30 to 24. If it's more than this, you have to go for this bearing. In this way, again we have to check the whether FA by FR is greater than E or less than E. Accordingly, we can calculate the value of P equivalent dynamic load. Then once you have calculated the dynamic load, you have to check whether calculated load is less, which is available in the catalog, or greater. If it's a less, you can say your bearing selected is suitable. If it's greater, you have to go for the next series of the bearing and repeat the procedure to calculate the equivalent dynamic load, because in equivalent dynamic load, FA by FR less than E and FA by FR greater than E, decide the equation for equivalent dynamic load and E value, which is going to change for different designated taper roller bearing. That's why we have to repeat this procedure. This is about the basic procedure of selection of taper roller bearing. Thank you. I have referred V. Bandari's book, Design of Machine Element, 3rd edition, McGraw-Hill publication, for this session. Thank you. If you have any query, please contact me through this WhatsApp number 98904226679 or mail me pvkushare@kkwa.edu.in. Thank you. Thank you very much.